Hey, Denell High School, this is Mr. Ayton, and this is the second podcast of stoichiometry. It's 1.2, Empirical Formula from a Decomposition Reaction. First, I have to explain what a formula is. A formula is just a ratio of moles. That's all it is. It's just a ratio of moles. Like water would have 2 moles of hydrogen for every 1 mole of oxygen. If we think about something like this molecule above, which is called glucose, C6H12O6, there's 6 moles of carbon, 12 moles of hydrogen, 6 moles of oxygen. And you might be saying, can't we reduce this, Mr. Ayton, to a 1 to 2 to 1 ratio? Yeah, the molar ratio is the same throughout. What's the biggest difference between this, between the true chemical formula and what we call the empirical formula? You can see the empirical formula is the simplest whole number one, the simplest reduced one. The biggest difference is the molar masses. Glucose, as a chemical formula, which is true, has 180 grams per mole. The simplest ratio of those moles is only 30 grams per mole. The true formula is 6 times as great because we have 6 times the number of moles. And so that is the difference between an empirical formula, the simplest, and the true formula, what it really is. So anytime you're looking for the true formula, you need to be given or need to be able to find out what the true molar mass is. Let me show you a nice problem. This is a very common problem. This is when we decompose something. Here we're going to take magnesium sulfate with something water. We call that a hydrate. There's some amount of waters. There's some amount of moles of water inside the magnesium sulfate. What are we going to do in the lab? We're going to heat it. And it says, what is the mass of the compound after heating? Now, there's a couple things. We have a big table of information here. And they ask for the moles of the water present in the hydrate. They're basically asking for the formula. Now, there's a few different things that we want to take a look at in this table of information. The big thing is, in this table of information, is we want to know the initial compound in the compound after we totally heat it. Everything else in between is just useless information. And the reason is there's still water in it. Now, if you see, the initial compound has the water in it. The compound after the heating has no water in it. So this 2.472 grams is magnesium sulfate. There's no water in it, which means how do we find the water? We got to take the initial 5.061 grams, which has water in it. We take the 2.472 grams, which doesn't have any water in it, and when we subtract this, and we end up finding 2.589 grams, that's water. That was the water that was heated off. If you see, we want to know the mass of the compound after heating, and we want to know the mass of the water. That's basically what all this data is there for. Now, guys, something I want you to see right now. If you see, everything in our data table was 4 significant digits. So from now till the end of the problem, I want to do 4 significant digits for everything. Everything. Let me first take the magnesium sulfate. If we have grams of magnesium sulfate, what's the only thing we can do if we have mass is divide by the molar mass. The molar mass of magnesium sulfate is 120.36 grams per mole. And that will give me 0.02054 moles of magnesium sulfate. Okay? Now, something I want you to see is we're trying to go to moles because we're trying to find the chemical formula, which is a ratio of moles. We're going to take the water and we're going to divide by its molar mass, which if we add everything up on our periodic table, it's 18.0158 grams per mole. And that will give me my moles of water, which is 0.1437 moles of water. Now, take a look. Both my moles answers, the one up here and the one down here, I rounded to 4 significant digits. I have 4 significant digits in each. Now, how do we find out what our ratio of moles is? A nice easy thing we did last year was we always divide by the smallest one. If you can't see the ratio there, now I can see it's a 2 to 14 ratio, which is the same as 1 to 7. But if you can't see it, divide by the smallest one. Divide by the 0.02054 if you can't see it. And we divide both of them by the smallest number. And when we do this, of course, 0.02054 divided by 0.02054 is 1. When we take this number and we divide by this, we end up getting 6.99. Now, guys, we can round that up to 7. All right. So we have a 1 to 7 ratio. Now, if this was 6.5, we can't round that up. We're going to double everything. If it's 6.33333, we're going to multiply everything, both of these got by 3. But if you see, here I have magnesium sulfate. I only have one of those. And what is X equal to? 7 waters. 7 waters. That is what X is, and that is the moles of the water present. This is an example of a empirical formula from a decomposition reaction. Guys, you're going to go into mrreading.com, go to AP Chemistry, look for the link to the Google Docs. I got a few little easy questions, and go to the 1.2. Thanks, and hope this was all right. Hope this was helpful. Thanks, guys.